So after we know what Bitcoin is, now let's discuss blockchain. So blockchain is the essence of a Bitcoin system, and we should understand it as block and chain. So what is a block? So block basically is a pile of information that records the transactions in the system. For example, A pays 10 Bitcoin to B, and B pays 5 Bitcoin to C, and C pays 2 Bitcoin to A. All right, and we have a lot of things going on here, and all of this information, okay, all this payments record, and the information associated with the record are compiled into one block, and this block has a size of a 36 megabyte. Okay, 36 megabyte. It's like you use your iPhone and shoot a video for 5 minutes, and the size of that video is 36 megabytes. So that's roughly 5 minutes iPhone video. Okay, which is not quite much. And as I said, not only you record all these transaction numbers, but also the other information associated with a transaction, like the anonymous address of the money senders and receivers, and also the account information of the sender and receivers, and also when the money is sent, like the timestamp and all the other information. Okay, and this will be compiled to one block. And the one block is not a video, is not a Word file with all the textures. It's not even numbers like 346 or any other or any numerical format, but it's rather a SHA-256 format. All right. So let me just take a closer look at this SHA-256. So as I demonstrated earlier, one Bitcoin is one bit is 1 digit. Okay, it's 1 digit, and this is a binary digit. It can only take 0 or 1. All right. So 1 byte. We heard this word in computer science a lot. 1 byte basically is 3 digits. Okay, it's 3 digits, and it can take the form of a 001 or 011 or 000 or 010 101 100 110 111. Okay, so there are 8 possible 8 possible formats of that. I shouldn't say format, it's just 8 possible expressions. So if it is 3 digits, so that's basically 2 to the third, which is 8 bits. Okay, 1 byte is 8 bits. And in a SHA-256, so basically that's 200 and the 2 to the power of 256, and this is almost a infinite number. It's very, very, very big. So let's just say if you have a block of Bitcoin transactions, which is 36 megabyte, and that is roughly 2 to the power of 28 bit. Okay, so you can see that's quite less than the 256 exponent. And if you have a Blu-ray movie, and that movie can take the maximum of 300 gigabyte, and you can see, wow, this must be very, very big amount of data. Then the data size is a 2 to the power of 41 bit, and still that's quite less than the volume or the containing volume of this SHA-256 format. Okay, so if you want to record a block of information with this much of a size into this a format. So it's just like you park a car in the entire continent of Africa. So there are ample space to put this information in a string of numbers. Okay, so now let me explain more about this SHA-256 function. So if I have a word, okay, just to say a word, this word is very random. Let's say banana. Okay, and I'm going to encrypt the word banana with into this SHA-256 format. So it will give me this 260 digits of 0, 1, and zeros, binary numbers. Okay, on and on. So there are 256 of them, and the process from banana to this string of numbers is called encryption. So it's pretty easy to put a banana, the word, to this string of numbers. It's easy to encrypt, but it's much harder to convert this string of numbers back to the original information, the word banana. So it's hard to decrypt. And when we encrypt and decrypt, we are utilizing a function called a hash function. Okay, so both the SHA-256 format and the hash function are designed and developed by the National Security Agency. All right, so this is a very ingenious invention in human history. Okay, so why do I say it's easy to encrypt here and it's hard to decrypt there? Let me just give you an example. All right, this is not necessarily the hash function, but just to show my point. Let's say I have a function of a cosine x plus x to the 7th plus log 4 x minus 3 that equals to y. So as you can see, if I know x, then it's pretty easy for me to solve for y, right? But if I know y, and it's very hard for me to solve backward to x, and there's no mathematical formula to use a known y to solve for x, so I can only solve by guessing. That's right, I can only solve by guessing. I can just randomly throw a number into the system to see whether that number is right or wrong. If it is wrong, I see how far this number is from the true answer. Then I will try another number which is closer to the true answer, and then try another number which is even more closer to the true answer until the final number I throw in is the true answer. So you just need to remember this. All right, so you can see, and sometimes if we put the encryption into the system, there could be 2 layers of information. Okay, 2 layers of encryption. So SHA-256, SHA-256. Okay, 2 layers of function to encrypt the word banana into the digits. Okay, into the string of digits. All right, so it's just like you solve for y equals to cosine x plus x7 plus log 4 x minus 3, okay, plus this whole thing to the power of a 7th, and then log 4, so on and so forth. So let's say if you know y equals to 101, and then you want to solve for x, well, you cannot really do it with your computer, with your hands, not even mentioning. So good luck to solve. All right. So what is the chain? All right. So we know block and then we know that those blocks have to be chained together. So a blockchain takes this format. All right, so assume these are the blocks. And each block actually is a string of digits in the format of a SHA-256. All right, so you can see that each of them has a lot of zeros and ones. The first digits, okay, the first several digits, a certain number of digits, it is the chain of those blocks. And then the rest of digits would be the block, okay? The block which contains the transaction information and all the Bitcoin amounts, all right? And we use this chains to connect all these blocks of information in the Bitcoin transaction system. Okay, so these are the chains, and these are the chain. All right, so the chain part is randomly generated by the system. Okay, it's generated by system. All right, it's by the designer Satoshi. Okay, and we also have the blocks. Okay, the blocks would be collected and built by the Bitcoin users, right? And each user will eventually develop not only a block, but they also will work on the chain. So that's why we call it a blockchain technology. All right. So there are a lot of users in the system, and they all want to build up these blocks and chain to the existing blockchain system. And there is an incentive for them to do it. Okay, everybody basically want to be the person or the user that built the block and connect it into the chain, just because they can get paid for doing it. All right. So now it comes to the very incentive rule of a Bitcoin. So if you can build up a blockchain, you would get rewarded, right? So your reward is 50 Bitcoin per chain, okay, per block you built, all right? And each block is actually it's a blockchain, and each block, according to the system, will occur in every 10 minutes, right? So when every 10 minutes eclipsed, there will be a block of information built and connected to the system. And when that blockchain is built up, a new blockchain is built up, there will be 50 Bitcoin rewarded to that user, whoever built the blockchain, okay? And that user is the luckiest one among all the users. And this amount of 50 Bitcoin applies for the first 4 years of a Bitcoin history, from 2008, when it was first invented, to 2012. And then the rewards amount will be reduced to half, to 25 Bitcoin in the next 4 years. Okay, and then in the next 4 years, it will get down to 12.5 Bitcoin, reduced by another half, so on and so forth. As you can see, the rewards will become less and less for the users to build the system.